have first the definition of period, right? So the scene here, period is defined as what? All right, Niste, let's go ahead and read what period is. Period P is
a repeating function has the number of the representing intervals such that
f of x plus t
equal f of x for any value of x.
Continue, please.
Oh, the period of the corresponding constant function is 2 pi. Period of the tangent and the cotangent function is pi.
Thank you. All right. Now, how we're gonna see those? Okay. So visually, a period is this. Like for example, if I type in sine. Okay. So how do we visualize period? Okay. So here it is. Let me just go ahead and erase this one first. This is what I'm gonna do. All right. I'm gonna go on the XY axis. Okay. I'm gonna click on radians. So I put in radians here. Now on the x-axis, I'm gonna put in the following, all right? 0 to 2 pi with step pi. Again, we are considering radians. Get it? Okay. And the y-axis, I'm gonna put in here negative 1 to 1, simply because we already know that the range is negative 1 to 1. Are we good for the y? So here it is. Now let's type it in here. Y is equal to sine x. Got it, guys? Okay. So as you may notice in sine x, one period is where? From 0 to 2 pi, right? So in here, this is what I'm going to do. I'm going to put in here, 0 less than or equal to x less than or equal to, 2 pi. Okay. As you may notice, that in there is one entire period or rotation for a sine. Are we good? Get it? For cosine, it's basically the same as well. Alright, so if I put in here, y is equal to cosine of x. If I remove sine first, look at that. That's for cosine of x, right? One entire rotation. That means on cosine, from its first peak to the next peak. Are we good? Right? In math, it's called the maximum value for y. Are we good? Okay. However, for tangent, it's different. Okay, so here it is for tangent. If I graph in here, y is equal to tangent of x. See that one, guys? Right? So that is y is equal to tangent of x. Now in here, the period is what? Pi. Right? So with that being said, let's put in here, what is this? From here to there, that's going to be what? From 0 to pi. Right, here's what I'm going to do. You see this one in here? 0 less than x less than pi, right? As you may notice in there, that's one entire period for tangent. Are we good? Right? Okay. If I can adjust it a little bit to the left by pi over 2 units, I can put in here what? From negative pi over 2 to pi over 2. Okay. See that part? Right? It just keeps on repeating, right? That's why it's called a period. It's a periodic function. That period just keeps on repeating itself infinitely on both directions, negative and positive. Are we good? Right. Now, how do we compute for that? So here it is. This is the computation for period. Given a format for sine, cosine, secant, or cosecant, if it's of the form this, A, the function, B multiplied to x plus c plus d. Whatever is the multiplier of your x, that's gonna be the period. Okay? I forgot something. Absolute value, right? Because sometimes it can be negative. What you're gonna do? Get the absolute value of that, right? Okay. Similarly here, get the absolute value. Whatever the multiplier of your x is for tangent, that's gonna be the b. By the way, those b are not yet the period. You're gonna use these triangles to get the period, right? So for example here, to get the period for sine, cosine, secant, and cosecant, what you're gonna do? for this triangle? You divide what?
2 pi
By b. Alright, so period for sine, cosine, secant, cosecant, it's 2 pi over b. However, for tangent, cotangent, to get the period, what's the formula? Pi over b instead. Okay. Are we good? Okay. Now, Mr. Deal, how we're gonna use this one for problems, alright? So in here, we got some problems in here to solve and see how we can work on this one, okay? Ready, guys? Ready? Okay, let's read this one. Number, 72 or 73. It doesn't really matter. They're basically the same. Let's read number 73, alright? You good? Yeah. Yancy, go ahead please.
The amount of sunlight in a certain city can be modeled by the function h equals 16 cosine 1 over 500d, where h represents the hours of sunlight and d is the day of the year. Use the equation to find how many hours of sunlight there are on September 24th and the 267th day of the year. State the period of the function.
Thank you. Good, so we have two questions in here, right? First, what? How long of a sunlight is there on that date? September 24. Okay, so September 24, what season is that? September. Is it summer or fall already?
Fall.
Fall, right? So is it kind of like start of fall? Is it the start of fall? Right? The start of fall is September 21, right? So it's right on the cusp, right? Like really end of summer and then just barely starting fall, right? 267th day of the year, okay? Now also state the period of the function, okay? So first thing that we're gonna do is to graph that one. So basically this, I'm gonna put it in here and analyze this function first, right? Again, h is equal to what? 16 cosine 1 over 500 d, right? So in short, your d is the independent variable and that independent variable is multiplied by 1 over 500, right? So basically, where is your b in here? This is your b, right? This in here is your b. How we good, guys? Right? So with that being said, let us now go here and analyze that here, right? So what's that again? H is equal to 16 cosine 1 over, what's that again? 500d. So your b is basically the multiplier of your independent variable d, right? So this is your b. Well, first, how do we get? So it's cosine, right? How do you get the period? Well, it says in here to divide 2 pi by that b. Are we good? Right. So that's what we're gonna do in here. Period is equal to 2 pi over that b. Right? So that's gonna be what? 2 pi over, what's your b again? 1 over 500, right? So what's that gonna be on your calculator? Just on the fractions, that's 1000 pi. 1000 pi. That's the period. Good? Right. So meaning, in this case, since that is cosine, we can imagine that one to be as follows, right? That one entire cycle for cosine from this peak to the next peak, that period is how much? 1000 pi. Are we good? Right? Which is what? Well, pi is 3.14, right? So you can imagine it to be what? 3,114 and so on. You good? Get it? 140 something, right? Anyways, let's see now how it looks like. So here it is. We're talking about cosine. Here it is, the cosine. and put in the whole thing. Y is equal to what again? 16 cosine. I'm going to put in here a parenthesis. And then I'm going to put multiplier of x as what? 1 over 500. You good? Okay. Now what I'm going to do in here, to change the x-axis from where to where? From 0 to, what's the period again? 1,000 pi, right? 1,000 pi. Get it, guys? Okay. But since your your d in here is what? Number of days, right? So we can think of that one as what? You know what? In terms of pi, you see the steps? I'm just gonna make this into what? Units, right? Or maybe by 10 days. Are we good? Or hundreds of days, right? Okay. So there we go. Now let's see where the graph is. So I'm just gonna click in here. Ooh, there we go. So as you may notice, since there's a 16 on top in front of it, that basically explains the maximum and minimum. You good? Right, there we go. So as you may notice in here, when you want just the one entire period, you're gonna put in here what? Brackets. Okay, well in here. Okay. So I'm gonna go here. You see this x-axis, I'm gonna put in here the following. 0 to, what's one period again? 1,000 pi, right? 1,000 pi. Are we good? Right? As you may notice, if you put that one in there, you would notice one entire period. Get it? Okay, so yes, we have already answered. The period is 1,000 pi, alright? Or approximately what? If it says approximately, that's 300, how much? 3,145 or 46 days. But anyways, how many number of days or how many sunlight amount there are at what day? 267th day. Good? So is that the x or the y? That's the x, right? Okay, on the 267th day of the year. So, you see this one? I'm going to put in here what? X is equal to 267 day of the year, right? And what does it say? Oops, there we go. Let me just go ahead and X this out. Okay, so that we don't have that one anymore. What does it say? That on the 267th day, how much sunlight hours do they have? 13.77 hours of sunlight. Are we good? Right? So, does that mean that there's more sunlight or there's less sunlight during that day? During fall? Is it more sunlight or less sunlight hours?
Less.
More, right? Is it more?
No, it's in the summer. Summer you have more hours of daylight, and in fall you get less.
Winter is the much lesser, right?
Yeah, winter
But
solstice is
yeah,
the 21st.
correct.
Right?
But when you are towards the summer, right, and this is just the end of summer, still more sunlight, right? So the nearer you are on that summer solstice, right, the more sunlight you're getting. Are we good? And when do you think was the summer solstice in here happened? Okay, let's see. You can check it out in there as well. Any questions, guys? Questions? So again, we have answered this question in here. Again, what does it say here? Use the equation to find how many hours of sunlight there are. On the 267th day, we say what? 13.7 hours of sunlight, or 0.8, right? And what is the period of the function? 1,000 pi. Right? And again, we can verify in our calculator if it's 1,000 pi days. Oops, how much is that? Yeah. 3,141.6 days. Are we good? All right. Thank you.